Okay, whenever you're ready.
Okay. Yeah. Welcome to Wales. I'm here to introduce. Start again in a second.
Do we need to stop?
Right, welcome to Wales. I'm here on a typical Welsh day. This is about as good as it gets here. Actually, no, we don't come out on field work in this sort of weather, but still. This is to introduce you to a spectacular new fossil site in the middle of Wales called Castle Bank. And just wanted to give you an outline of how the geology works, and because it looks like a perfectly ordinary quarry. There are thousands of quarries like this around Wales, but most of them don't have these fossils in. So it's actually a very short sequence, but right at the top of it, up here, if I can get there, at the top part of it is actually volcanic ash. So we're in the middle of what is called the Builth Llandrindod Inlier, which is basically a fossilised volcanic island sequence. And this is only a very short section of it, but at this time there were lots of volcanic ash beds which were erupted sort of quite violently, and then the ash was settling down through the water. So you get layers like this, the top 2 meters. There goes my hat. Right, where was I? Yes. And underneath that, this is just absolutely typical black mudstone. Very fine sediment that filtered down to the seafloor and contains lots of fossils of graptolites and tiny little brachiopod shells. Graptolites are planktonic, quite closely related to us actually, little colonial creatures. So we've got a couple of meters of that, then this really lovely white volcanic ash bed here, which is actually still squidgy. You could sort of make that into clay and make pots out of it. Never tried that yet, but then it gets interesting. So below the ash, we start getting much harder rock, and this is, well, around here we start getting fossil sponges preserved. These are extremely delicate creatures, so their skeletons are extremely fragile, and to get them preserved at all, you need to have them buried alive, effectively. So the next 2 meters, we get exceptional preservation of mostly sponges, until you get down to about here. So there's one band about 20 centimeters thick, which contains layers up to just a few centimeters, which have been transported. They're sort of slurries of mud that have flowed down the slope underwater, been buried in, or sunk down into a sort of little hollow where it was, we think, anoxic with no oxygen, and they've carried little creatures with them. And in these beds, in some of them, we actually get soft-bodied animals entirely preserved with tiny little tentacles, internal organs, things down to 1 millimetre or 2 only. So very, very small animals, completely soft-bodied and preserved intact. And then you get little bits and pieces of that, so little worms and so on in the next sort of metre or so, and then it gradually goes back into perfectly normal rock. So this is all what you would get in any outcrop around here, lots of graptolites. Very, very occasionally you'll get something else, but it's mostly completely normal. So really, it was just that one interval of a couple of meters, but especially 20 centimeters, where you get really excitingly preserved little beasties. Right, let's see what we can find something. So you can see in this layer here, there are these harder bands which come out as big blocks, which is very unusual for this sort of rock. Normally it flakes into tiny little pieces. But this is the event beds, these layers of slurries that are washed down the slope, and will hopefully have quite a lot in it. But they're not the easiest things to split. Yeah, that's too big. The fossils are tiny, so you can just break them down this way, and then hopefully there'll be something in here. Actually have to wait a little while for the fossils to darken as well, because sometimes they're completely invisible when you first split it. There's tiny little flakes of graptolites or something, nothing useful yet. Again, more bits of graptolite, still nothing exciting. And sometimes you just don't get anything at all in the layer that you've picked out, which of course is inevitable when there's a camera on it. Ah, hang on. There's something black here. It's about 1 millimetre or so. Yeah, that is the right preservation. There's something small and black and partly embedded, so it's going to need a microscope to be able to tell what on earth we're looking at and whether it's interesting. So I'll just put that to one side for the moment and carry on going in case there's something better. Aha! More black things. After a while you just get used to what the right preservation looks like, and you can immediately spot something that's part of a soft-bodied fossil. This is sponges. Got little bits of sponge in here. Yeah, may not be anything too exciting, but it's there, and they've got bits of the spicules that make up the skeleton. You probably can't see anything from that distance, I guess, but there are little bits of sponge in here. Let's see. Most rocks you would not really break down very far at all, but with here, because the fossils are so tiny, you have to actually keep going on until you really can't split it any further. So here we're down to flakes about 3 or 4 millimetres thick, but we haven't stopped yet. Nothing in that one. Helps being really short-sighted. Ah, there we go. There's one of these tiny little tubes. So it's something organic. It's well, we know what this is because it's one of the most common things here. But it's a tiny little tube which has not been described yet. So something completely organic, about 1.5 millimetres long in that case. So it's worth having a little look at that. I don't think there's any soft tissue in it, but still. When you get a nice big surface like this, it's always quite exciting, and then normally there's nothing on it at all. But once again, there are some tiny little black flecks on here.
Is it exciting not knowing what the black flecks are?
Kind of exciting, yeah, because sometimes you can have a fairly good idea of what you found in the field, and it just, the microscope confirms it, but other times we've actually found some of the best fossils have been ones that we haven't even really recognised in the field. We've just taken back a little tiny flake of carbon thinking it might be nothing, and it turns out to be an arthropod with legs and little spiky bits sticking out and so on. So just the scale of this is quite hard to work with in the field. This is only the first stage. More sponge spicules. They get everywhere.
So, as a sponge expert, what can they tell us? Like, what kind of environments did they live in? What kind of animals are they? Yeah,
sponges are actually very, very abundant in relatively quiet conditions. So offshore environments, in the deep ocean especially, they dominate in a lot of seafloor areas. So in terms of ecology, it doesn't tell you that much because they're everywhere. But what they can tell you is a lot about their evolution, because they're a very understudied group. And some of the sponges that are turning up here are very modern. They're much more advanced than we'd expect them to be at this time. And so it's really quite peculiar. And they tend to be the rare ones. The common ones are the ones you'd expect. And then you get occasional examples of things which are much more unexpected. But you get little fragments of the sponges all over the place, just the spicules. But the thing is, the silica is dissolved, like all of the minerals that make up the skeletons of these things. The calcite, the phosphate, all of it is dissolved, and the only thing you're left preserved is the organic material. So we're dealing with just one group of sponges in particular for these isolated spicules that have organic layers in the spicules, which is not common today. So it's a very odd type of preservation, and there are some layers where we can get the silica preserved in sort of silicified layers a bit further up, and there you find the spicules are everywhere. So almost all of them are gone, and we're just getting either the organic ones or the ones with the soft tissue, the actual body fossils. So I'm still seeing just tiny little flakes in here. You have to scour every single surface to see what you can find, if anything. But yeah, it takes a little while to find the good stuff.
How often do you make finds? Is it like one every hour? Is it one every day?
It's really varied, but we always find something good. And once you get to the right layers, then every time you split it, there'll be something soft-bodied in it. But it might be, an hour or 2 or 3 before you actually get one of these beds which is particularly prolific. Most of them you just get the odd fragment here and there. Now, this one has several brachiopods in. It's got exactly the right sort of preservation. I can see silvery bits. I can see little black bits appearing now. It's starting to oxidize a little bit. Yeah, this is a sort of layer that we would take back and put under the microscope because you'd probably miss things in the field. But there are definitely little brachiopods, and yeah, that's one for the microscope, I think.
I'm excited.
Me too. We've been stuck indoors all winter because you can't work until it warms up and the sun comes out. And so we're hoping for something really good this year. Oh, what we got there? Graptolite. Yeah.
Yeah. Oh.
It's just the common one, unfortunately. There are lots of more exciting graptolites as well. Actually, I say that. Is it?
Oh, here's a Discovery Live.
Oh. Unfortunately, my hand lens are steamed up. Oh, I think that's something a bit different. It's got little fibrous things in it. It might... Yeah, I think that is something different. That's one for Lucy. Where is she? There you go. Come and have a look at that one. I'll carry on hammering. I'm going through this actually probably quicker than we would when we're out here working. And it would take a long time to go through very much material at all. And of course, with most fossil sites, you just wouldn't bother splitting things this size. But this is often where the best bits are here. It's not the best spectator sport. And you never know what is going to turn up with the very next block that you hit. But on the other hand, usually it's nothing.
That's the addicting part. Can you leave it at the end of the day?
It's quite hard, actually. When we start getting hungry, then it's normally a safe bet. It's time to go. But no, it's very hard to drag us away from some of these quarries. Lots more brachiopods. There's this one tiny little brachiopod, just a couple of millimetres, little round thing, which, it's a quite interesting one because it was partly pseudoplanktic. So it was partly living attached to graptolites.
Whoa!
Floating around in the surface. We know this from one other site where we've actually got them still attached to the graptolites. And partly just living on the sea floor, but it's hugely abundant. And in fact, in the Bill-Thin layer, if we find a site without this micula, a Paterbolus micula, we get quite excited because it means something weird was going on. But there are lots of... there is something here. Still partly embedded as it usually is, but that's another thing to look for. Look at under the microscope. It's got the right sort of browny, carbonaceous preservation. Might not be anything exciting, but we'll find out with the microscope.
Right, so I've been asked to talk a bit about graptolites while hammering, so I will do that. Graptolites are one of the most common fossils here, which is really handy because they are very, very good for dating rocks. Ooh, I've got half a trilobite here. Not a very good one, but I'll put that aside carefully on that bit of the rock. Yeah, graptolites, no one really knows what they are, unless you're a zoologist or a geologist, but they are a largely extinct group. They have some modern relatives called Rhabdopleura, which are very obscure and live in the undershells in the sea, form little creeping colonies, and no one's ever really seen. Most people have never seen one. But the graptolites that we find most commonly here actually floated or swam. That's a big controversy, but they must have at least been able to move a little bit in the top layers of the sea and fed on plankton. And they evolved very rapidly, and they were very diverse. There were a lot of species. So if you know which species you're looking at, you can tell the age of the rocks very exactly. So, which is why we've got a very, very good framework for understanding the ages of Ordovician Silurian rocks and being able to tell which rocks around the world are the same age, which is actually a really big thing. You know, if I'm looking at an event that happened here in Wales, did that happen at the same time as something in China or before or after? That's the sort of thing you're really interested in if you're trying to work out how diversification patterns worked, for example. So we're quite lucky here that we've got a reasonable assemblage of graptolites. We've got a thing called Didymograptus murchisoni, named after Sir Roderick M.P. Murchison, who was the person who to define the Silurian system, so a very famous geologist. And they're a tuning fork shape, so they're shaped like that. So very easy to identify, and we've got thousands of them in this quarry. And that gives us the age quite well, but it's always nice to have the age from more than one thing, just in case something survived a bit longer in one place or appeared a bit earlier in another place. So we've actually got a couple of other species. We've got another one called Proclimacograptus angustatus, which is a very common and actually quite a long-ranging species. That's not so useful, but it's consistent with having the Murchisoni. And then we've got another species called Diplograptus foliaceus, which again is quite a well-known one. We've only got one specimen of it, but it's a very nice specimen, so we're sure that's what it is. So we can pin the age down to the Didymograptus murchisoni zone of the Darwinian stage of the Ordovician system. In fact, of the Middle Ordovician. So we've actually pinned down the age very, very exactly. It's actually somewhat more reliable than dating radiometrically by using something like potassium argon dating to get an exact age, because that's always got error bars on, and the error bars tend to be longer than the age of a graptolite biozone. But it's about 461, 462 million years-ish. So I think I'll get on to find some more graptolites.
We have this sort of grand dream of being able to basically understand the built-in layer entirely. So it's something like 10 million year history. There's 150 odd sites that we've got within walking distance of our house, and all of them are parts of a jigsaw. So what we want is to understand the whole picture eventually. So anytime we find a pile of rocks lying on the side of a hill, we stop and look because it's something new. It's just a new bit of information. And found loads of graptolites straight away, and then a few little black blobs that look like they might be sponges, and I like sponges, so we took them away for the microscope, confirmed them, and this was 2013. So
eventually we found out where the spoil had come from, which was this quarry we are currently standing in, and we came back to collect more sponges because Joe likes sponges, and kept finding more sponges. Got quite a good collection of sponges, and then COVID happened. And we were supposed to be going back to China, but that didn't happen. So we thought, well, we'll just get a few more sponges from here and write it up and do the paper. And
yeah, so I just thought I'd have one more day in the field just to get the last few bits before I actually just finish the thing and write it up completely. And of course, that's the day when soft-bodied fossils turn up. So we've been working fairly randomly through the quarry, finding where the sponges were all the way through, and I'm just trying to pin down a few last little bits of the distribution of them. So working a little bit more systematically in one area, hence this little bit that we're working in now. And it turns out that the exceptional fossils were not just in a tiny area or a tiny thickness of rock, but also in the blocks that we weren't bothering to split, because the sponges tend to be on the surfaces, whereas all the soft-bodied stuff was inside them.
So we've been coming here collecting for something like 7 or 8 years and had completely missed all the soft-bodied really interesting things.
Which is slightly embarrassing, but there we go.
But then we found them, so we've done, a few hundred days in the field perhaps over the next few years.
Yeah, a couple of hundred, something like that.
So we've got a fairly good idea of what's where now. And it turns out that the best exceptional preservation is in that little band there, but there's some in higher beds and a bit in lower beds, so it is all the way through to an extent.
Yeah, but the problem is we very rapidly discovered that these fossils are tiny, between 1 and 3 millimeters on average, and they have extremely fine detail which our microscopes couldn't handle. Because we're living here not as academics in a university, but we're doing this largely as a hobby now. And so we had to actually get access to much better microscopes. And the only way we could think of doing that, which was suggestion of the landowner actually, was crowdfunding.
Yeah.
So we thought that'll never work. And then we got 18,000 quid's worth and ended up with better microscopes than most universities.
So we can study the fossils and publish them and let everyone know about them.
Yeah.
And we'll still keep coming back out this summer and see what else we find, because there might be something wonderful in the very next block.
You never know.
Yeah.
I really want one of those spiky lobopods.
So do I.